Hey everybody, so I want to make a quick video talking about the errors that you see when you're working with the unit testing, like the test scripts here in your Python files. I want to make this video really quick though. I don't really want to talk about it forever because it's not really necessary, but we're going to kind of cover this a little bit. So let's talk about this. So we're just going to jump right in. So you don't have to worry. You can look through the test script. It's not cheating. You can feel free to look through the test script. I mean, as long as your code passes the test, then we know that it does what it needs to do. But you shouldn't try to hard code your code to make it pass the test explicitly. But anyway, so let's look at the test conditions file. I think that would be a good one to test because there's a lot of ifs and stuff going on. So I think it makes a little more sense. So, um, so let's take a look at this. So we have the first example here. So what I want you to see, again, when you're looking through the test code, don't worry about all the class stuff. Don't worry about all the with IO as buff or whatever. It doesn't matter. Don't worry about this. This is just getting the print output, essentially. That's all that line is really saying. These are the parts I really want you to focus on because these are where your errors are going to come from. The assert errors, the assertion errors is what I really want to talk about here because that's where almost all your errors are going to be. Because, like, duh, that's exactly what all the errors are going to raise. So, note to self, don't start recording at 11 o'clock at night. Okay, so let's talk about this. So in the first function, if you remember, when you wrote this function, the purpose is just to return if the number that you pass in and the string that you pass in, if the number is longer than the length of the string, or bigger, I guess. Or I guess it's kind of the other way around. If the string is, like, the length of the string is smaller than the number or whatever, it doesn't really matter. But you get what I'm trying to say. I mean, you wrote the code already, so it's like, it makes sense. But what this error is saying is this first, well, it's not really an error, but what this first line of code here is saying that I have highlighted here is it's saying we need to assert that this function returns none. So this block of code, when you return anything, and I can show you this, when you return anything, your function's value will be equal to whatever it is you returned. Like here, we returned, we returned x, and x was 5. So here, where I called this function, if I set this equal to a variable, or I don't have to set it equal to a variable, but because I did, the variable is now equal to whatever this function returned. But what I want you to focus on is this block of code right here where I called the function, even if it has a bunch of inputs in the function call, same thing. This block of code now represents what we returned. That's why that keyword is very important. Printing the value just shows it in the console, but it's not really helpful if you have to pass that value into another function. That's where the difference is. But anyway, that's just a quick refresher on printing versus returning. But so anyway, if your function properly returned something, then this would be equal to something. This wouldn't be none. But since your function wasn't really supposed to return anything, it was just supposed to print stuff, then we want to make sure that your function isn't actually returning things. This is why we include this test case of is none or is not none, because we really want you guys to understand the difference between printing and returning. And it's not really fair for people who just print and then return every single function. They're not really learning what the difference is, and it's like that's why we want to have a test case to make sure that your function is not returning or is returning what it needs to be returning. So if you ever see an error that says assertion blank is not none, or blank, something does not equal none, or none does not equal something, it's because you're either printing or returning something and you're not returning what you should be returning, or maybe you never even included a return statement, then it's definitely not going to equal whatever it should be. It's always just going to be none, because if you never put a return statement in your code, your function will always return none by default. In fact, you can actually see this real quick. I'll show you. If I take a look, it's like, see this function here, I never returned none. This function, I did return none explicitly, but take a look at this. If I hover over this function, it'll say, look at that, there's that error there, the arrow that points to none, and what that means is this function returns none. And see, if I do the same thing here, look, it's there also. So like functions will return none no matter what you do, unless you return something explicitly that isn't none. This value could be none. I could have set this to none and it would have returned none. But because it's not none, it will return 5. Or whatever x is, technically. Which is 5. So, anyway, so if we go back here, that's what that is none assertion means, is that we want to make sure that when we call your function with these values, or really just in general, we want to make sure that it's returning, like, or not returning anything, essentially, because it's just supposed to print stuff. Okay, moving on. The next part here, when you're probably going to see errors like this pop up a lot in your code, and whoops, I clicked on the scroll bar there, sorry. What I want you to see when you see an error like this, like a test failed error, blah, 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 and then it's going to say self.assert equal, and then it would say this, and then the buff, and it would just say, you know, blank does not equal blank. And it would say like exclamation point equals, which means does not equal to. So when you see an assertion error like that, essentially what that would mean is that we're trying to say, we want to make sure that your output here, if you ever see the buff.getValue, what that means is you're printing something. So we want to make sure that your printed output matches what this string is. Now, one thing I can recommend to you guys is, like, one possible thing that you could try to do, although this might be slightly more advanced and may just cause you more problems than it's worth, but it is an option. Instead of printing whatever it is you're supposed to be printing, maybe just at first try to just build it up as a string and then see if the string matches up. And then if the string matches, you can just save that to a variable and then just print the variable. I mean, it's the same thing. And then you can like inspect it and see like what specifically it's doing, especially in debugging. If you do debugging, this really helps. Anyway, moving on. And then here we called the function again, and we wanted to make sure that the assertion value was the same. So we're saying, okay, when we call this function, it needs to equal this string. So if I call your function with earwax and I give the number 5, then it should print out longer than 5 characters earwax in this exact format. If you have an extra space here, or a space before the colon, or an extra space here, or like you didn't capitalize the L, doesn't matter. It could be anything. If it does not match exactly, then it will assert this error. It will like, or not assert the error. It will raise an exception. It'll raise an error, an assertion error specifically. So that's what assertion errors are. And that's what I want you to realize is when you see these assert equal or assert is not none or assert is none, that's what we're doing when we're testing your code. We're trying to see if your functions are returning the proper things or printing the proper things in the proper format that we want. That's it. That's literally it. That's all of the unit testing errors. All of them are going to be exactly those things. Like, I'm scrolling through the entire file. They're literally all those things. There's an assert is not none. We haven't seen that one yet, but we kind of already talked about it. But like literally assert none, assert is not none, or sorry, assert is none, assert is not none, and assert equal. Those are all the 3 kinds of things that we use in our unit testing. Literally just 3 kinds of assertion statements for pretty much every possible like test script that we write. And that encompasses all of our errors. So now when you see those errors, you shouldn't, I mean, you know, I'm not saying you shouldn't feel bad or should feel bad or whatever, but you shouldn't worry in the sense of like, I don't know what this means, because it's like, well, now you know. It's saying, okay, if you see this error pop up in one of your errors, you should say, okay, well, I can see the code that raised this error. So what happened? One other thing I want you to like keep in mind, and I would really love if you guys did this, and this may sound like a cheat almost, but it's good. It's a fun kind of cheat in a way. It's not really cheating, but one thing that I would recommend is if you're running the test script and you're getting errors, one thing that might help you is open up the test code itself in the text editor. Like how I have it here. I opened up the test conditions.file or test conditions.py file. Jesus, I'm tired, man. It's been a long day. Anyway, I open up this file and I can see, like, let's say I got an error here. Like maybe I just forgot to capitalize the letter or something. I don't know. So I got an error here. Well, I can see right there, it's trying to call my function with earwax and 5. Unfortunately, I don't have any code written out to actually go back and show you the conditions file and all that. I could probably show you a student's code, but I'm not going to do that to them, especially when it's being recorded. But essentially, I could go and look into my file here in my function. I could go look in my word-length function and say, okay, what's the logic? What does the logic do when I pass in a 5 and when I pass in this kind of string that's like 6 letters long and the number is 5? What does my function do? What are my if statements going to evaluate to? Now that I have actual values, what is my code actually going to do? And then what's it going to print out? And just follow it like line by line, section by section in each line. And eventually you will get to exactly why your error is popping up. That's what I really want you guys to understand about assertion errors. They're really simple. Really, really, really simple. I promise you. It's just a matter of fixing the bugs gets a little more complicated because it's like, could be a logic thing. You know, you could have a really complicated code that has to go through like 7 different if statements and this while loop and then a for loop inside of the while loop and just all kinds of crazy stuff. So it may not always be easy to actually get it to assert what it needs to assert and get your code to return what it needs to return, but I digress. The actual understanding the errors themselves are very, very simple. Very, very easy to understand. Now, sometimes you'll see in these assertion errors, you'll see like pluses and minuses. I'm not 100% solid on these. From my understanding of these, though, I'm going to do my best to explain it. I could be slightly off on here, but I'm going to do my best to explain my understanding of these. When you see the pluses and minuses on these like assertion things, like I know, for example, you see it in stoplight, and I'm sure you probably see it in all the others too. But because I remember seeing them for some people who had the stoplight problem. But when you see the pluses and minuses, generally what it means is, I think the minuses, like the pluses and minuses are the test expected string, what the test code is expecting, and then one of them is the string that your code is outputting. Now, it's not always easy to tell which one is the test string and which one is your string. So what I would recommend is try to look at the error itself. Don't look at the plus minus crap. I mean, it is helpful because sometimes it's like pretty obvious. It's like, oh, I'm missing a space or whatever. But what I would recommend is take a look at the assertion error that was like, this will show up. If I got an error that says like yellow does not equal red, then or like yellow does not equal green or some other error here, I can look at this exact line of code. This line of code will show up in the shell. It'll show up like slightly above that error. And I can say, okay, it's trying to say that my function should equal yellow. Now, again, let me cover this real quick. We're going to kind of do a refresher again of what I just said like 5 minutes ago. But when you return something, it sets your entire block of code of your function call equal to whatever it is your function returns. Right here, just looking at this line of code, I can tell that when I call the stoplight function with the string of green passed in and the number 61 passed in, I can obviously tell that it wants us to make this equal to yellow. This should return yellow. Why do I know that? Well, because the test script is saying that this function should return yellow, because if we are asserting that the string of yellow is equal to this function call, if I'm asserting that some data is equal to a function call, then that means that that function call needs to return that data. So that means that given those inputs, our function call needs to return that data. Now, this gets into like cheating territory though, because you could just have a bunch of if statements that say, okay, if the user gives us green and 61, then yellow. If the user gives us green and 60, then green. If the user gives us green and 59, then green. You could theoretically do that, but we will catch you because we do actually, what I'm grading, I actually do read through all of your code, and I actually do look at the logic. Like, I may not be looking at it with a magnifying glass or whatever, but I am actually looking at your code. And if you do this, I will catch you. Like, I'm serious. But but I want you to think of that conceptually though. Like, maybe don't code that exactly. If green, then and 61, then yellow. But what I'm saying is, when you run your code, you can see the arguments that it's giving when it tries to run your functions. It's saying, okay, run the user stoplight function and pass in the argument green and pass in the argument 61. When we pass in these inputs, the function should do whatever it is it does. And then it returns, and it should return yellow for those particular arguments. So that's assertion errors. And that is the assertion equal errors. So if you see errors, or sorry, if you see lines of code like this, where it says like assert equal and then some string and then the buff get value, what that means is assert that this string that we are expecting the user to give us is equal to whatever we actually printed to the console. That's a refresher. That's that. If you see a line of code like this, that should clue you in to say, okay, I see a function call. So we're saying that this data type, which is a string in this case, needs to be exactly equal to whatever my function returns. So we know that my function needs to return a string, and specifically we know exactly what string it should return given these inputs. And this also shows us what kind of inputs that we're going to be passing into our function. So, I mean, I know it tells you all this in the directions. It says your function should return this, this, or this, and they're going to be strings, and you're going to need parameters that represent an integer and a string and blah, blah, blah. I know this is already given to you in the directions if you just read, but what I'm saying is in the test code, you can literally see the exact arguments that it's going to try to use for your functions, and that's really helpful. That's really helpful. You guys don't realize when you write code in the real world, you don't always know what people are going to pass in your functions. I mean, you're kind of the controller here. You're kind of like, you have control because you're the one making the functions. You can enforce things and you can, you know, write your code in such a way that you're assuming that users are going to pass in an integer, but you don't always know that they're going to pass in an integer or a string or something. I mean, they could pass in something else. Maybe they just, and that happens to me all the time. I'm using other people's code from different libraries that I'm importing. I'll import in a library like how you guys imported the math library or the turtle library. And it's like, it's not always clear what I'm supposed to be passing into these functions, even with the type hinting and even with the variable names that people give for their parameters. It's still not always clear. Like sometimes, for example, I see the variable name file as a parameter name, and it's not always clear if that means, should I pass in a file object or does it want me to pass in the name of the file, which is a string? And even if it's the file name, do I need to pass in the relative name? Or do I need to pass in the full path? Is it going to convert that? Does it have a way to know that? Because if I pass in the full path to that file from like C users, login documents, whatever, if I pass in the full file path, like, is that going to break? Because maybe it adds in its own file path onto that, so it's just going to break this. Like, it's not always clear, and it's not always clear what the function is actually going to do with your inputs. So this is why this is like super helpful to see, like, okay, I know exactly what the user is going to give me when they try to run my functions. Like, I know what the tests are going to try to do. So it's like, perfect. Now I know exactly the range of values I should be expecting, which again, should be clear from the directions, but it's just helpful to see it from your own eyes, basically. So anyway, I'm not going to talk too much longer. That's that. I'm not going to ramble on forever about this because I would just be repeating myself. It's literally all the same. But yeah. Oh, one more quick refresher. If you see self-assert is not none or self-assert is none, usually that means that your function either needs to return something or doesn't need to return something, or it needs to print something or doesn't need to print something. If the assert is none, if it's saying assert is none, you can guarantee that your function should be printing something instead of returning something. If the assert says is not none, then you know that your function should be returning something. Because, like, if I pass in something for the pant size for, like, say I pass in 38 for your pant size function, I should get something back. It shouldn't be none. If it was none, that would mean that you probably printed the pant size, and I'm assuming it would be large. I haven't looked at the directions in a little bit, but based on this, I'm assuming that it should be large. And you probably printed large instead of returning large. If I returned large, this would now be equal to large. That's exactly what that string would be equal to, because that's what returning does. It sets that block of code of the function call equal to whatever it is that it returned. So that's what those mean. And then you see like self-assert true and false here, and that's the same thing. It's saying that this function call should be equal to, meaning it should return either true or false, nothing else. And this is a little bit tricky. I see sometimes people do this where they say like return true, that's not what we want. Because that's just a string that's true. Instead, you should actually write the words true or false. That's what we want. I just want to clarify that. I see that pop up sometimes on the topic of common errors. Okay, I'm going to shut up now. We've been talking for 20 minutes. But I think I covered all of my notes. Yep, I did. Cool. Okay, awesome. If you guys have any more questions and you want to learn more about Python and all this stuff, please feel free to ask. I'm always happy to help explain stuff. Helps keep my mind occupied from otherwise unsavory thoughts, and so it's always or it's always a good thing for me. I'm always happy to help. So, and it means a lot to me. I really appreciate your guys' feedback, and I appreciate helping you guys out. You guys are wonderful students, and you guys work really hard, and I'm very proud of that, and I'm very appreciative of that, and it doesn't go unnoticed. And in turn, I try to work really hard for you guys. So it is what it is. Anyway, yeah, we're gonna end it there. I hope you guys have a great weekend, and or whatever it is when you're watching this. But yeah, I hope you guys have a great day, and thanks for watching. Bye.